Hello everyone, today in this video we'll be discussing the first module of electronics point questions, and then in this PDF we have 8 questions which are the most repeated ones from the model paper and the previous papers. And before starting, please do like and subscribe, it helps me make more videos like this. Don't miss any of these questions, these are the most important ones. So without wasting more time, let's get started. The first question is, what is regulated power supply? Okay, what is regulated power supply? We'll be having a look what it means. Okay, it's a very important concept, and we'll have to also make a neat diagram for it. Okay, neat block diagram. Then we will explain the working of DC power supply and mention the principal components used in each block. Okay, so 4 questions are here. One by one, let's see. Okay, what is a regulated power supply? Okay, a regulated power supply ensures that the output currents remain constant even if the input changes. Okay, so what happens? Output is same. Okay, even if the input is changing. Okay, input is increasing or decreasing, but the output is constant. Okay, this type of configuration is called as the regulated power supply. Okay, it changes the unregulated AC to a constant DC. Okay, it changes unregulated AC to constant DC means the AC means alternating current. Okay, it will be changing. Constant DC means it will be constant like this. The process of converting this thing into this thing is done by the regulated power supply. Okay, so most of the electronic devices are operated by DC power supply. That's why we want to convert from the AC to DC. Okay, to do that a thing is used. In that thing there are 4 components. Okay, this is the first one, second, third and fourth. So we'll be having a look what are these things. Okay, the first thing is the AC current. Okay, you know what is AC current, right? If we see this diagram, that will be more easy to understand. See here, the AC current is always changing. Okay, it becomes positive, then it becomes negative based on the timings. Okay, so what happens? High voltage AC current is supplied to step down transformer. What does transformer do is it will convert the higher voltages to lower voltages. Okay, means this length, right? This length will be decreased. Okay, transformer does that thing. This is higher voltage, this is lower voltage. So firstly it converts high voltage to low voltage. Who does that? The step down transformer. Okay, after that rectifier is used. Rectifier means if the negative cycle is present, that will also become a positive cycle like this. Okay, that is the work of a rectifier. Second step is rectifier, it will convert to unsmoothed direct current. Alternating current will have negative cycles also, direct current will have only positive cycle. Okay, after that we'll be using a filter. Okay, what does filter do? Filter will convert these waves to a smoother wave. Okay, like a straight constant wave. Okay, so that is the thing which is done by the smoothing filter. And finally we will be having the fourth component, which is voltage regulator, which will be converting this to a constant regulated direct current. Okay, so this is the process of a regulated power supply. Okay, and this is the neat block diagram. Okay, there's just another representation of the same. You have to make this one. Okay, along with the waveforms. Next question, what is a rectifier? Okay, we had a look at the rectifier in the above diagram, right? So there are different types of rectifier as well, and a half wave and full wave rectifier also. Okay, so I have to explain those things. So what is a rectifier? Rectifier converts AC voltage to pulsating DC. Okay, see what does rectifier do? This one it converts to this one. Okay, see the negative things gets removed and the equivalent of positive for that negative gets added up here. Okay, so it converts all the negative cycles to positive things. Positive cycle, that is the rectifier. Okay, so there are 2 types of rectifier. One is the half wave rectifier and second is the full wave rectifier. In half wave rectifier, it will convert the half cycles, negative half cycles into the positive half cycles. Okay, only on either positive or negative half cycles it will convert. Okay, so this is the diagram you need to make. There is 240 volts here. This is the primary circuit and this is the secondary circuit. Okay, 2 circuits are here, primary and secondary. Okay, 240 volts will be converted to 12 volts. Okay, and this is the resistance RL. Okay, that's all you have to make here. Okay, so when the current is flowing like this, in that time the conversion happens from 240 to 12 volts and it becomes positive. Okay, during the negative half cycle, what happens? There will be no current flow because the D1 will be open circuit here because of the reverse bias. Okay, firstly it will be forward bias, so there will be current, then conversion will happen. In reverse bias there will be no conversion happen. So what happens when the negative half cycle is there? It will not be having any output. Okay, so see here, in the negative half cycle, this is a half wave rectifier. In half wave rectifier, all these gets cancelled out. Okay, nothing will be present here. Got my point? This is the half wave rectifier because only half wave, whatever is there, will be coming here. Negative half will be cancelled and nothing will be there. Okay, that is half wave rectifier. In full wave rectifier, what happens? This also a positive will be there. How does that happen? That happens because of Okay, in the full wave rectifier, what happens is we'll be having two waveforms. Okay, so because of two waveforms, we'll be getting circuit here also. Okay, that happens because of this. First is this one where the negative half cycle will be removed and the positive half cycle will be taken from D2. Okay, equivalent of positive half cycle will be taken from D2. Okay, that is what happens in the full wave rectifier. Okay, it is also called as biphase rectifier. So see, like this it happens. Okay, it was negative here, it will become positive here. Okay, and this is because of C1 RL with C1, it becomes a more smoother wave. Okay, moving on, we have what is our voltage regulator. Okay, what is voltage regulator, and with a neat circuit diagram explain the operation of zener diode. Voltage regulators with using zener diode. So basically, what is voltage regulator? Regulator means continuing, making it. Okay, like that. So voltage regulator means generating voltage. Voltage regulator is a circuit that maintains a constant DC. Okay, maintains a what? Constant DC output voltage. It will maintain a same output voltage irrespective of the variations in the input line voltage or in the load. So input voltage becomes high, low like that, but the output will always remain the same. That is the work of a voltage regulator. Okay, and it is one of the most important application is the zener diode. We'll be using the voltage regulator in zener diode. Okay, so some key points are it is included to limit the zener current to a safe value. Okay, when load is disconnected. Okay, that is the first key point. There will be a safe value because of the limit. Okay, and when the load is connected, the zener current Iz will fall as the current is diverted to the load resistance. Okay, so when it is connected, what happens? The zener current will fall because of the converted to the load resistance, diverted to the load resistance. Okay, and the output voltage will remain at the I'll be explaining using a diagram. Okay, RS and RL are the two resistors present. Okay, so output voltage Vz will remain at the zener voltage until the regulation formed by RS and RL falls lower than the input voltage. Okay, so see here, this is the formula. Vz is equal to Vn into RL by RL plus RS. Okay, and the power will be equal to Iz into Vz. The zener current into zener voltage will give us the zener power. Okay, power of the zener diode. Next is what is voltage multiplier, and it mentions its applications and before the operation of voltage doubler circuit. By the name, what you can understand, voltage multiplier. Multiplier means multiplying it or increasing it. Okay, it is a modified capacitor. Okay, what it is? It is a modified capacitor filter that delivers a DC voltage twice more than the peak value of the input AC voltage. If this is the peak value of the input voltage 10, there will be a regulated power supply voltage supply of 20 in the output. This thing is done by the voltage multiplier. Okay, so it is used for high voltage and low current devices and can be found in the modern TVs and in the spray painting equipment also it is used. What happens when the spray is present here, right? So when it sprinkles here, some voltage is applied so that the spraying where we spray at the cars, right? So car is made of metal, so when we add some voltage here, what happens, it will get attracted to the metal and means stick to the point where it's actually required and does not waste. Okay, means all the particles will stick at different places and none of the place will remain empty because of the voltage we applied. It became magnetic and it will be sticking here. Okay, so it helps in spreading an even coat of paint. Okay, this is the advantage. Okay, and this is the circuit diagram. Okay, here we'll be having two diodes, D1 and D2. D1 will be like this, D2 will be reversed. Okay, and the output is taken from C1 and C2 connected in series. Okay, output is taken from here. Moving on, we have a numerical. Okay, so a numerical which says the following measurements were made using during a test on amplifier. Voltage in and voltage out is given, and current in and current out is given. We have to find out voltage gain. Okay, what is the voltage gain? Okay, and the current gain. What is the current gain? Okay, and the power gain. If we have the voltage and current gain, we can calculate the power gain, and the input resistance we can calculate divide. How we can calculate? Resistance is equal to V by R, right? Sorry, V by I, voltage divided by current. Okay, so let's have a look. So firstly, four things which they have given: the input and output, voltage and current. We'll be writing here. Voltage gain is equal to V out by V in, so we'll get 40. Current gain is I out by I in, that is 160. Multiply 40 and 160. Okay, we will be getting the power gain. Now what is the resistance? Input resistance is V in by I in, and that will be 100. This is the input or resistance they had asked. V in by I in we have to take, okay, because in the input resistance you have to consider the input voltages and input currents, okay. So this is a important numerical, don't miss this one. Moving on to the next concept, we have the concept of negative feedback with a diagram. Okay, negative feedback means if the current is flowing and whatever the result we are observing, that result is not what is expected, so a feedback will be given so that unexpected output will be seen in the next iteration, like that. Okay, that is called as negative feedback. Okay, so some key points for the negative feedback are, firstly, it improves the bandwidth. Okay, why we use it? To improve the bandwidth, reduce distortion, and control the gain. Okay, means how much current is getting passed and all, that can be controlled, and reduce distortion and bandwidth can be improved. Means how much output we are getting based on the input. Okay, and it can be reduced to manageable value if we have the negative feedback. Okay, if there is a lot of feedback going which we don't want, we can reduce it by using a negative feedback, and if you want to increase it, we can use the positive feedback. Okay, so the circuit diagram is given here, can go through it. Okay, this is the diagram you need to make, and this is the formula, the calculation. Okay, how we got the formula. So the overall gain with the negative feedback is applied will be less than the gain without feedback. Okay, if there is no feedback, what gain we have, right? More than that gain, sorry, lesser than that gain we'll be having with negative feedback. Okay, because negative feedback will reduce the gain which we are trying to get. Okay, that is the main aim of it. Okay, so if the voltage amplifier current is more larger, very larger, in that case we'll be using the formula G is equal to 1 by beta. Okay, beta is the constant and G is the gain in the current. Okay, now this is the formula. First is V in, and that V in formula will be V in dash will be calculating, and by that we'll be calculating the V in value. Okay, and the V out value is AV into V in dash. This is the internal gain. Okay, AV is the internal gain. Now the overall gain will be V out by V in. These formulas will substitute these both formulas, and we will subtract, means simplify it. So you'll be getting AV by 1 plus B into AV. That is the gain formula. Okay, that is the final thing you need to write for this question. Moving on to the next one, we have a numerical where it is the numerical with respect to the zener diode. Okay, a 6-volt zener diode has a maximum rated power of 500 milliwatts, and it is used in a simple regulated circuit to supply a regulated 6 volt to 500 ohm resistance. Okay, see, this is the zener diode which is having the power of 500 milliwatts and a regulated power supply of 6 volt it outputs, and with a resistance of 500 ohm, and determine a suitable values of series resistor for supply of 12 volts. For 6 volts it is 500, for 12 volts we need to calculate how much it is. Got the point, right? So firstly for that we need to calculate the zener current. Zener current is IZ. Okay, so we have the power, we have the voltage, so zener current will be equal to power by voltage. Okay, so we'll get a zener current 83.3 milliamperes. Next we have to calculate the load current, which is going through the resistance 500 ohms. Voltage is this, 500 is the resistance, so the current going through the resistor is IL 6 volts by 500 ohms. The voltage, load voltage by load resistance, which is 12 ampere, will get 12 milliampere. Now the current which is in series, okay, series resistor current, that will be IZ in plus IL, both summation of the zener current plus the load current. Okay, that is the total current we'll be having, series current, that will be 0.0953 ampere. Okay, and since we have the resistor current, now we can calculate the resistor value, which is RS. Okay, so here the voltage is 12 volt which they had given. Okay, and zener voltage is 6 volts, so the voltage drop across the resistor is, we have to subtract both of these to get the actual voltage which is left, that is 6 volts. Okay, now the resistance is nothing but voltage by current, right? So voltage we have 6 volts, we have calculated it here, and the current we have got is 0.0953. So we'll be dividing 6 volts by 0.0953, we'll be getting 63 ohms, and the closest standard value to 63 ohms is 68 ohms. Okay, that's the last thing you need to write. Okay, moving on to the last super important question, we have what is the amplifier and the different types of amplifier. Okay, amplifier means increasing. What does amplifier do? It will increase. Okay, it is an electronic device that increases the voltage, current, and power of a signal, and it is used in wireless communications and broadcasting and audio equipment of all kinds. Okay, so there are few types of amplifiers we'll be having a look. So the first one is AC coupled amplifier. Okay, in AC coupled amplifier, what happens? The components are transferred from states to stage. Okay, so a current has both the AC component and DC component. So AC coupled amplifiers, what it do? It will just take the AC components and amplify it, and DC will remain same. DC coupled amplifier will do the reverse of it. Both AC and DC components are transferred from stage to stage. Okay, AC only AC will happen. In DC, both will happen. Okay, and large signal amplifiers, it will amplify the large signals for the typically values from 1 volt to 100 volt. Small amplifiers less than 1 volt. Audio frequency amplifiers 20 to uh, 20 hertz to 20 kilohertz. Okay, that audio frequencies it will be amplify. Wide band amplifiers, it ranges from few 10 to tens of hertz to several megahertz. Okay, and radio frequency 100 kilohertz to 1 gigahertz. Low noise amplifiers, it will whatever the negligible voice is there, the disturbance to the signal being amplified, that it will remove. Okay, these amplifiers are used for design for very small signal levels less than 10 millivolts. Okay, so these are the ranges present. Based on different ranges, the amplifiers are separated. Okay, so one of the most important parameters of an amplifier is the amount of amplification of the gain provides. What is the main task of amplifier? To increase the value, right? How much it increases, based on that the categorization is done. Okay.
The next question is describe the operation of a switched mode power supply SMPS with a neat diagram. Okay, so this is the block diagram which is present. The input will come from here and the input will get rectified and filtered. Then high frequency switching will happen. Power transformer will be there and output rectifier and filter, and the DC output will be the output. Okay, so this is the alternating current input and this is the output. Okay, and this will go to the control circuit and that will be converted to PWM signal, and that will again the process will repeat. Okay, so basically it's that. So the whole operation is nothing but we are making the conversion of unregulated input signal to regulated DC output signal. Okay, so major components are input rectifier and filter, high frequency switch, power transformer, output rectifier and filter, and control circuit. Okay, just as how I explained, those same things are only present here. Okay, you can just go through it once. Next question is define input resistance and output resistance in amplifiers. Input resistance in of an amplifier is the resistance offered by the amplifier at its input terminals to the signal source. Okay, and the formula is given here. Output resistance is the resistance offered by amplifier at the output terminals. Very simple. Input resistance, input terminal, output resistance, output terminal, and this is the equation given. Okay. Next, these are the numericals. I'll be just quickly going through it. You have to practice these types of numericals. So in this question, they have asked about the zener diode, which has a maximum rated power dissipation of 500 milliwatts. Okay, if the diode is to be used in a simple regulator circuit to supply a regulated 5 volt to load having a resistance of 400 ohm, determine a suitable value of series resistor for the operation in conjunction with a supply of 9 volt. Whatever is given, you have to note down that first. Okay, so voltages are given and the resistance value is given and the power is also given. Okay, so RS max we have to find out. That will be nothing but RL into V in by Vz minus 1. Okay, so we'll get the RS max value, and RS min value also we have to find out. That will be nothing but V in into Vz minus Vz square by Pz max. Okay, that will be 40 ohms. Okay. So, like that only we have another question in which the following data were obtained during a test carried out on a DC power supply. Okay, load test is equal to output voltage is this much, output voltage of 2 ampere load current is this much, regulation test is this much, voltages are given, determine the equivalent output resistance of the power supply and regulation of the power supply. Okay, so here again we have to find out the R out and the regulation values. So we'll just apply the formula, change in the output voltage by change in the output current, and we'll get this value here. Same thing we'll do the for the regulation as well, change in output voltage divided by change in line out input voltage into 100%, we'll get this value also. Okay, so that's all what we have to do for the output voltage regulation. Okay, an amplifier produces output voltage of 2 volts for an input of 50 milliwatts, and if the input and the output currents in this condition respectively 4 milliampere and 200 milliampere, determine the voltage gain, current gain, and power gain. Three types of gains you have to find out. So each of these gains will be writing the formulas and will be applying the values which are given in the question to find out the answer. Okay, here they have asked an integrated circuit that produces an open loop gain of 100 is to be used as a basis for amplifier stage having a precise voltage gain of 20. Determine the amount of feedback required. Okay, so G is equal to AV by 1 plus BAV. Rearranging the formula for the B, we will be getting the B value here. Okay, that is the amount of feedback required. Okay.
The first question is explain ladder network with a circuit diagram. Okay, so what is a ladder network? So this is the ladder network. Okay, what happens initially there is a negative cycle, right? Then what happens in the output, positive cycle comes there, and wherever positive is there, negative comes there. So there is a phase shift happening. Phase shift means what is the angle that is getting reversed by 180 degree. Okay, so this is the circuit diagram you have to make. Two resistors are here, followed by three capacitors, each with a resistor here, and there will be a TR1 here, and there will be a capacitor with a another resistor here. Okay, that's all. This is the V out, which is which we are taking the output from, and this is the input. Okay, from here the input will be there. Now a few key points related to the ladder network is TR1 operates as a conventional common emitter amplifier stage with R1 and R2 providing base bias. Okay, so TR1 is the emitter, common emitter. Okay, and R1 and R2 is providing the bias. Okay, and R3 and C1 are providing the emitter stabilization. Okay, R3 and C1, this part is providing stabilization. Okay, these are the 2 points, and total phase shift provided by CR ladder is 180 degree. Okay, these are the key points you need to write. And the loss associated with that network must be compensated with the transistor amplifier in order for the circuit to oscillate. Okay, whatever the loss is there, that has to be compensated by the transistor. Okay, and the frequency formula is also given. This is also another key point you need to write. Okay, so from the ladder network oscillator, first you will be writing this diagram, and you'll be writing these key points which are discussed. Okay, moving on to the second question, which is explain what is multivibrator. Okay, and the principal types of multivibrator with suitable circuit diagram. Explain single stage multivibrator using operational amplifier. Okay, op amp. Now, what is multivibrator? In multivibrator, we are going to get a square wave. Okay, normal wave it will convert to a square wave. That is called as a multivibrator. Okay, so multivibrator use regenerative positive feedback, and active devices are present within the oscillator, and those are known as switches. Okay, principal multivibrators are astable multivibrator and monostable and bistable. Okay, astable provides a continuous stream of pulses, monostable produces a single output pulse, and bistable produces two stable states. Okay, and requires a trigger from one state to another state if it wants to change. Now single state stage astable multivibrator will be like this. Okay, here there will be a resistor followed by op amp here, and this will be capacitor followed by two resistors here. Okay, and this is the waveform. This is the capacitor voltage, and this is the output which gets converted into the form of square waves. Okay, and astable oscillator using op amp with waveforms. Okay, this is the key point in it, right? Initially C is uncharged. Okay, capacitor is uncharged initially, and the voltage at an inverting input is slightly less than the voltage at the non-inverting output. Okay, this is the inverting output, and this is the non-inverting output. Okay, in the inverting output it will be slightly less than the non-inverting output, and the output voltage will rise rapidly to plus VCC, and the voltage at the inverting input will begin to rise exponentially as the capacitor C charges through R. Okay, so what happens when the capacitor gets charged? Okay, this is the capacitor when it gets charged. Okay, when it gets charged, what happens? The voltage rises to VCC, the inverting output voltage, as well as the capacitor gets reversed. Okay, the voltage at the inverting end gets reversed. Okay, so what happens? The waveform which we will be getting is in this form. Okay, like this form we will be getting the output. Okay, so that was about the multivibrator. Moving on to the third super important question, we have with an circuit diagram, it describes the operation of C controlled oscillator. Okay, crystal controlled oscillator. Okay, so this is the diagram you need to make. This is the output which will be getting, and the diagram is as follows. Okay, here we have the resistor and the inductor and capacitor, and here we have the common emitter. Okay, this is the diagram you need to make, and here what happens, it should maintain the same frequency. The main thing of crystal controlled oscillator is that exact frequency of the oscillation is maintained. Okay, so quartz crystal is a thin slice of quartz. Its sealed enclosure vibrates whenever a potential difference is applied across its faces. Okay, this effect is called as piezoelectric effect. Okay, and the frequency is determined by the crystal's cut and physical size. Okay, you have to write these key points and make this diagram and corresponding waveform also. Okay, moving on, we have the next super important question, which is define the following with respect to operational amplifier and write its typical values. Okay, so first is what is open loop voltage gain. Okay, this is a very much repeated question. The definitions. Okay, open loop voltage is nothing but it is defined as output voltage ratio with input voltage ratio. Okay, and in practical, it is very high value greater than 1 lakh. Okay, it can be thought of as an internal voltage. That is the open loop voltage gain. That is output voltage divided by input voltage. Okay, V out by V in. Okay, next is input offset voltage. Okay, what is input offset voltage? Input offset voltage is that an ideal amplifier would provide zero output voltage when zero difference is applied. inputs. Okay, whenever a zero output is means whenever zero voltage is provided, there will be zero output voltage. Okay, so the amount of voltage that must be applied differentially to the operational amplifier in order to make the output voltage exactly zero. Okay, initially it will not be zero, but some voltage we will be applying so that the output voltage is zero. That whatever we apply is called as input offset voltage. Okay, and its range is from 1 to 5 millivolts. Okay, next is full power bandwidth. Okay, full power bandwidth is maximum undistorted peak voltage that falls to 0.07. How much power we apply so that the voltage falls to 0.07 of the low frequency is called as the full power bandwidth. Okay, and it ranges from 10 kilohertz to 1 megahertz. Next is slew rate. It is a change of output voltage with respect to time. Okay, that's all. It is a change of output voltage with respect to time, and the rectangular step input voltage is applied. When the step input voltage is applied, at that time how the output changes with respect to time, that is the slew rate. So it is V out by delta T. Okay, means voltage divided by time. Moving on to the next super important question, we have sketch the circuits of each of the following based on the use of op amp along with input and output waveforms. Okay, we have to sketch what use of op amp. Okay, circuits by using op amp along with input and output waveforms. Okay, first one is voltage follower. Okay, what does voltage follower do? It is a non-inverting amplifier in which 100% of the output is fed back to the input. Okay, and the result is that voltage gain of 1 will happen. Okay, and a very low input resistance will be there. That is the voltage follower. Okay, next is the differentiator. Okay, in differentiator you will be having a circuit diagram where two inputs will be there. Okay, v1 in and v in out, and there will be a resistances here which are followed by op amp here. This is the differential amplifier. The gain will be output by input, which is nothing but v in minus v in 2 minus v in 1, the differences between the second and the first voltage, and multiplied by the resistances rf by rin. Okay, rf is this one and rin is this one. These both are same. Okay, that is the gain which we are going to get in the differentiator. Next one is integrator. Okay, in integrator we will be having the resistance and capacitor here followed by an op amp here, and this is the v in and v out. Okay, so this is the input voltage which will be in a square form and the output voltage will be in a triangular form. That is an integrator. Okay, next one is the comparator. Comparator means comparing two voltages. Okay, v1 and v2 are present. We are comparing these two voltages. Whichever is the bigger voltage, that will be having a higher value. Okay, so this is the input voltage at here and this is at here. Which is greater? This one is greater, so there will be a high point here. And here also, if you check, this is greater than this point here, so this will be having another high value here. Okay, so this is called as a comparator. Whichever will be having a higher value, there it will be a higher one. Okay, means vs will be higher. And wherever a change happens, see, at this point a change is happening, right? After this point this is higher, right? After this point this is higher and this is lower. So what happens, the lower one will be considered here. Okay, output voltage will be higher or lower based on these two values. Okay, whichever is greater or smaller. Next is write a note on ideal characteristics of op amp. This is also very much super important question. There are 6 characteristics of an ideal op amp. First is that the output voltage gain should be very high. Okay, output open loop voltage gain, and input resistance should be high, output resistance should be low. Okay, see, open loop voltage gain should be very high. The voltage which you are going to get from it, that should be very high. Input should be very high in resistance and output resistance should be very low. Full power bandwidth should be wide as possible. Okay, maximum range covering bandwidth of the full power. Input offset should be as small as possible. Slew rate should be large as possible. Okay, just remember these few points, and if you write this much, that should be sufficient. Moving on to the last super important question, we have the wein bridge oscillator using op amp. Okay, so in bridge oscillator, you have to make this diagram. Okay, you have to make this shape here and write A, B, C, D. Okay, A and B are the inputs and C and D are the outputs. Okay, and 4 resistors will be there, 1, 2, 3, 4. Except that here there will be a parallel resistor with a capacitor. Okay, and this is the equivalent circuit diagram. This and this both are same. Okay, and this will be the output. Okay, you just have to make the diagram waveform like this, and this will be time t. Okay, now the key points you'll be writing is, first is the network provides a phase shift which varies from the frequency. Okay, what does wein bridge do? It provides a phase shift, means 0 to 180 like that. Okay, and input signal is applied to A and B, and output is taken from C and D. Okay, at one frequency, the shift produced will be exactly 0. When it will be 0? When C1 will be equal to C2 and R1 will be equal to R2. Okay, at that time this will happen. This is the formula you need to write: minimum amplifier gain. Okay, minimum amplifier gain, if it is required to sustain oscillation, in that case C1 by C2 plus R2 by R1 should be equal to AV. Okay, in most cases C1 and C2 and R1 R2 will be equal, phase shift will be 0, and this will be the frequency. Okay, when R1 equal to R2 equal to R and C1 is equal to C2 is equal to C, at that time phase shift will be 0, and the formula is given by this one. Okay.
The next question is explain list the ideal characteristics of op amp. Okay, op amp is operational amplifier characteristics. Okay, the characteristics for ideal operational amplifier are: the open loop voltage gain should be very high. Okay, the input resistance should be very high. The output resistance should be very low. Full power bandwidth should be as wide as possible, and slew rate should be as large as possible. The input offset should be as small as possible. Okay, so these are the ideal characteristics of op amp. Explain the following: slew rate, input offset voltage, and CMRR. Okay, so slew rate is a rate of change of the output voltage with time when a rectangular step input voltage is applied. Okay, slew rate is V out by delta T. Okay, the next one is input offset voltage. The voltage that must be applied differentially to the operational amplifier input in order to make the output voltage exactly 0 is known as input offset voltage. Whatever input we have to give to make the output as 0, that is the input offset voltage. Okay. Now, CMRR is common mode rejection ratio. It's an op-amp key parameter that measures how well the amplifier rejects unwanted signals that are common to both the inputs. Okay, higher CMRR means better noise immunity and more accurate amplification of the desired differential signal. Okay, and this is the formula. You have to write this formula as well. Okay. Next one is how op-amps can use this integrator with necessary output equation and the waveforms. Okay, so this is the integrator you have to make, and this is the waveform. Okay, this circuit provides the opposite function to that of a differentiator. The output voltage of ramp up or down according to the polarity of the input. Okay, it is opposite to the differentiator. Integrator is opposite of differentiator. Op-amp as an integrator, it has the following things: in the inverting mode, the resistor R is connected between the input signal and inverting input. Capacitor C is connected between output and inverting input. Okay, non-inverting input is grounded, so the capacitor replaces the usual feedback resistor, making the op-amp perform integration. Okay, the output equation derivation would be input current through the resistor. This current charges the capacitor, equating currents, and rearranging the terms will be obtaining this equation. Okay, integrating both the sides. The final equation you have to write this one. Okay, of the V out. Explain the operation of three-stage ladder RC network oscillator with a neat diagram. Okay, a simple phase shift oscillator based on three-stage CR ladder network is shown below. It operates on the conventional common emitter amplifier stage with R1 and R2 providing the base bias potential and RK and C1 providing the emitter stabilization. Okay, so this is the diagram which you need to make. Okay, and the total phase shift provided by the RC ladder we have to calculate it. The frequency of the oscillation of the circuit will be getting is 1 by 2 pi root of 6 CR. Okay, the loss associated with the RC network is 29. Therefore, the amplifier must apply a gain of at least 29 in order to for the circuit to oscillate. Okay, these are the key points you need to write. Write a short note on crystal control oscillator. Include the working principle and waveform. So crystal control oscillator, the requirement of some oscillator is that they accurately maintain the exact frequency of the oscillation. In such cases, quartz crystal can be used as a frequency determining element. It determines what frequency it has to run with, and quartz crystal vibrates whenever a potential difference is applied across its phases. The frequency of oscillation is determined by the crystal's cut and physical size. Most quartz can expect to be stabilized the frequency of oscillation of a circuit to be within few parts in a million. Okay, so they can be manufactured for operation in fundamental mode, and the frequency range can be extending from 100 kilohertz to around 20 megahertz. For the overtone operation of from 20 megahertz to well over 100 megahertz as well. Okay, and this is the diagram which you need to make. Okay, a simple JFET oscillator. Next one is draw and explain the working of an inverting and non-inverting amplifier configuration using op-amp. Derive their voltage expressions. So these are the diagrams. Inverting amplifier, this is non-inverting amplifier, this is differential amplifier, and this derivations are there. Okay, both of the derivations are given. You can go through it. Okay, that's all what you have to write for the derivations of op-amp.
Write a note on different types of modulations and briefly describe each in detail. Okay, so basically what is a modulation? Modulation means changing. Okay, modulation means changing. the process of varying one or more properties of a carrier signal, okay, usually a frequency sinusoidal wave with the information signal. There are two signals, okay, one is the carrier signal and one is the information signal, okay. So along with the information signal, the carrier signals acts as a cover on it, okay. Means if this is the information signal, the carrier signals will be like this, okay. Carrier signals will carry the information, okay, that is the carrier signals, and these are changed. Carrier signals are changed based on how information is changing, that is called as modulation, okay. And different types of modulation are, first one is analog modulation. In analog modulation, we'll be modifying either amplitude or the frequency or the phase will be changing, okay. So if we change the amplitude, it will be used in radio broadcasting, and if we use the frequency, it will be used in the FM radio, and if we use the phase model, change the phase modulation, in both of these it will be used, okay. And it is a change in proportion to the message, what it is, okay. If the message has a greater change, the modulation will also be greater only, okay. The second type is the digital modulation. In digital modulation, the message signal is digital, either 0 or 1, and the carrier wave is varied according to the digital signals. It can be either the amplitude shift keying, where the amplitude of the carrier wave is varied, okay, and frequency carrier wave, where frequency of the carrier wave is varied, phase shift keying, where phase of the carrier is varied, okay. And if we do the combination of this, it will be called as quadrature amplitude modulation, okay. It allows for higher data rates. The second one is brief about the modern communication system with its need diagram, okay. What is the modern communication system? We have to brief, okay. So it is a complex network designed to transmit information over the long distances. It uses the digital technologies, advanced modulation, and networking protocols to achieve higher data rates and the robust error correction and flexible connectivity. So key characteristics of modern communication system. First characteristics is it is digital transmission, okay. It is transmitted in the form of bits and bytes, okay. And multiplexing is possible. Simultaneously, it can be transmitted using time division multiplexing or frequency division multiplexing. Modulation is possible here. Error correction is present, and networking is present. We can transfer the data from one point to other point using the different networking techniques. Okay, and wireless communication is also present using the Wi-Fi, satellite, or cellular networks. So here, few of the concepts are there. In the wireless communication, information source is there, that is transferred to the transducer, and which will be transmitted to the transmitter, and transmitted signal is sent to the channel in which the noise is also included, and in the receiver side, output oscillator will be removing the noise, and the final destination will be from the information source, it will be reached to the final destination, okay. So these are the key points in the wireless communication. Moving on, we have the next question. List out the advantages of digital communication or analog. Digital is the bits and bytes it is getting sent, and the analog is like this one, okay. So what is the advantage of this one, and with respect to the analog signal, okay. So first is noise immunity. Digital signal, noise cannot enter. Why? Because it is either 1 or 0. There is no in between, so noise cannot enter here. Second is regeneration. We can regenerate digital signals perfectly. Why? Because either 1 will be there or 0 will be there. But for the analog signal, either some decimal differences can come. 0.151 it is, will be by mistakenly taking 0.49. It will be a little bit difference, but here it will be either 0 or 1, so it will be more accurate, okay. And efficient multiplexing is possible here. We can send it to multiple signals, and flexibility and integration is possible at the digital end. It is more secure, cost effective, higher data rates is present. We can transfer more data digitally than analog, and simplified implementation is simplified, and error detection correction is possible. It is much more complex in analog systems, okay. Moving on to the next question, we have explain with the need diagram concept of radio wave propagation and its different types, okay. So the radio wave propagation happens through the air, okay. It can happen through the earth also. There are different types of it, okay. So it can happen ground, space, or sky, okay. So the frequencies in which the radio waves operate is 10 kilohertz to 300 gigahertz, okay. And this is the transmission medium, either ground, space, or sky, okay. So first is, let's discuss the ground surface. In ground surface, the radio waves are guided by the earth and move along its curved surface from the transmitter to the receiver, okay. Second one is the space or tropospheric wave propagation. Here it travels as a straight line to the space, and from there it reflects and comes back to the earth, and it is about 15 kilometers from the surface of the earth, okay. The space wave is made of two components, direct wave or the short wave, okay. So two types of things are there in the direct wave. That is the direct wave or the ground reflected wave, okay. Direct wave is formed from directly transferring from the transmission to the receiving antenna. Ground reflected wave is happened when it's reflected from the space back to the antenna from a satellite. Okay, so the television frequencies are 100 to 220 megahertz. The third one is the sky wave. In sky wave, the radio waves are transmitted from the transmitting antenna into receiving antenna after reflection from the ionosphere. It goes to the ionosphere, which is the ionized layers lying in the earth's upper atmosphere. And short wave transmission around the globe is possible through the sky wave via successive reflections at the ionosphere and the earth's surface. Okay, so three types are there: ground, space, and sky. Okay, based on the range and the how much more data is to be transferred, we'll be using different types. Okay, moving on to the next question, we have: consider the following binary data and sketch the ASK, FSK, and PSK modulated forms. Okay, so this is the data given to us, and we have to construct ASK, FSK, and PSK. ASK is amplitude shift keying. Okay, so in ASK, the carrier signals varied to represent the binary data. A higher amplitude represents a 1 and lower amplitude represents a 0. Okay, higher means it will be 1, which is the higher amplitude carrier wave, and 0 is the lower amplitude carrier wave. Okay, next one is the FSK. FSK means frequency is changed. Here also 1 is higher frequency and 0 is lower frequency. By that case, we'll make the diagram. That will be the FSK diagram. PSK, carrier shift with respect to the phase shift. If the phase shift is 0 degrees, it is represented by 1. If it is 180 degrees, it will be 0. Means if different phase is present, it will be 0. If the same phase is present, it will be 1. Okay. Moving on to the last one question, we have: explain the types of communication systems. There are two types, it varies. The first one is based on physical infrastructure, second is based on the signal specifications. Physical infrastructure, two are there: line or radio communication and simple or duplex communication. In line radio communication, we will be having like this things, right? If you might have seen somewhere in the road and all, there will be lines like this. That communication is the line or radio communication. And second is the simple duplex communication. Simple communication will be one way, duplex will be both the ways. Okay, that type. So two types are here. Second is based on signal, nature of baseband signal and nature of the transmitted signal. Okay, if we consider on the nature of baseband signal, baseband means transferring the data in the form of electricity. It can be either analog form or it can be digital form. And nature of transmitted signal is can be either baseband communication or carrier communication. In baseband communication, one type of data will be transferred. Okay, and in carrier communication, multiple data will be transferred within a single line. Okay, so
the next question is: define modulation, explain amplitude modulation with a neat waveform. Okay, modulation is the process of varying one or more properties of carrier signal with the information signal that needs to be transmitted. It is done to make the information signal suitable for transmission over a communication channel. So amplitude modulation is the way in which we use the amplitude to modulate it. Okay, so if I show you the diagram, the amplitude modulation will be like this. If you want the signal to be like this, carrier signal will be like this, information signal will be like this. If we combine them both, we'll be getting this one. Okay, so this one will be the one which will be finally used. This is called as waveform of amplitude modulation. It can be clearly seen that from the figure that modulating signal seems to superimpose on the carrier signal. The amplitude variations in the peak values of the carrier signal exactly replicate the modulating signal at different points of time, which is known as envelope. Okay, with waveforms, explain ASK, FSK, and SPK modulation technique. ASK is amplitude shift keying. Okay, so there will be different types of keyings. ASK represents the digital data as variations in the amplitude of the carrier wave. Okay, and based on the amplitudes shift, we will be transferring the data. That is called as ASK. Okay, next is FSK and SPK. FSK is the frequency shift keying. Based on the frequency shifts, the data is transferred. Phase shift keying, based on the phase shifts, the data is transferred. Okay, so that is the phase shift keying. Next one is: what is multiplexing? Explain different types of multiplexing in a communication system. Multiplexing is a technique that is most widely used in nearly all types of communication systems, radios, lines, and communication. It means it which allows more than one signal to transmit through a single channel. The use of multiplexing also makes the communication system economical because more than one signal can be transmitted to a single channel. Multiplexing is possible in communication system only through modulation. If it's modulated, it will be possible to multiplex. Okay, so this is the diagram which you need to make. Okay, and types of multiplexing: frequency division multiplexing. It is based on the frequencies. The applications are in radio broadcasting, television, and cable TV. Second one is the Time division multiplexing, based on the time slots, the channel is divided and each signal occupies a channel for a short duration of time. Applications are digital telephony, PCM systems, and data communication networks. Third one is the wavelength division multiplexing, which is used in the optical fibers. It uses different wavelengths, colors of light. Okay, types are CWDM and DWDM. Okay, applications are high speed optical fiber networks and internet backbone systems. Code division multiplexing is CDM or CDMA. It uses the same frequency band, and at the time a unique spreading code is used. Okay. Next one is the space division multiplexing. Here, the different signals are transferred separate physical paths or antennas. Okay, so it is called as space division multiplexing. The next one is compare analog and digital communication system. List the advantages of digital communication systems. So differences is the nature of the signal. If you talk about it is continuous in time, this is discrete. Either it will be 0 or 1. Noise immunity, highly affected by noise. This is less affected by noise. Signal quality degrades gradually. It maintains the quality. Bandwidth requirement, it is lower. It is generally higher. Error detection is difficult in analog, whereas it is easy in the digital. Processing uses analog circuits, uses digital circuits. Storage, difficult and inaccurate, easier and accurate. Flexibility, less flexible, highly flexible. Hardware is analog filters and amplifier. This is digital ICs and processors. Security is less secure and this is more secure. So basically you just have to remember one of them and the opposite will be valid for the other one. Okay. Advantages and yeah, advantages are basically any five you can remember: high noise immunity, error detection and correction, better signal quality, whatever you have learned at the top, right? The differences that same are the applications also, advantages also you can write the same one. Okay, security, high reliability, low cost. Okay. Next is write short notes on the noise and its effects on the communication system. Noise in communication is defined as unwanted random disturbance that interferes with the useful information signal during the generation, transmission, or reception, resulting in signal distortion or errors. Types of noise: one is the external noise, which comes from the atmospheric noise, man made noise, or cosmic noise; internal noise, thermal noise, short noise, flicker noise, and transmit time noise. Effects of noise in communication system: a signal gets distorted, reduction in the signal to noise ratio, increase in bit error rate, loss of information, degraded system performance, and interference with the reception. Noise reduction techniques: how can we reduce the noise? Filter the unwanted things, shield and ground to reduce external interference, use of amplifiers with lower noise figure, and increasing the transmitted signal power and error control coding in digital communication. Okay.
Let's get started. The first one question is the difference between the embedded system and the computing general computing system. Okay, so basically embedded system means that whatever the devices we have, right, whatever the device like the washing machine, AC, mobile phone, refrigerator, all those things which run by electricity, they have an system inside it. Okay, because of that system we are able to perform the operations which we are able to perform. Like for example, in an AC, if you want to convert the temperature from 16 degree to 20 degree, that operation, when we click on the remote, what should happen, that is defined in the embedded system. Okay, the systems which control the entire device is called as embedded system. Okay, and general computing system means it's a general computer like whatever we have a normal computer, right? So the normal operation which can be performed on it, all those things are coming under general computing system. This is for the generic use and this is for a specific use defined for that object. Okay, so the differences between them are these. You can remember any five of them. Okay, so first is purpose. It is for a specific task. This is for a general purpose task. Many things can be performed on a computer, but for this it is dedicated for a specific task. Okay, and it is optimized for that task, often minimal. It is more powerful and flexible hardware for many other different things we are using. It is a real-time operating system specialized for that thing, and this is general purpose like Windows, Mac, and Linux. It is designed for lower power consumption, and power consumption is higher here because more tasks are being performed. Cost is lower, cost is higher because complex hardware is there and more functions are present in general computing systems. And it often have the real-time constraints. Here it does not have the constraint. Limited memory, more memory, and no UI. This is having a rich user interface, difficult to update or maintain, easier to update and maintain. And examples are microcontroller in automotive system, medical devices, and here desktop or computers or servers. Okay, so applications are also given here. Few applications are for the embedded system. First is in consumer electronics like mobile phone, digital cameras; automotive like the engine control units and ABS, anti-lock braking systems, airbags, all those things which are present in car. And third is industrial automation like the programmable logic controllers, robotics, medical devices like the insulin pump and blood measure monitors, networking routers, switches, aerospace we have the flight control and navigation systems, in military we have missile guided systems, home automation we have the thermostat, security systems, lighting control, in IoT we have smart sensors, wearable devices, in transportation we have the traffic light controllers. So all of these come under the embedded systems. Okay, and the general computer system, it's just a normal computer PC and mobiles. Okay, next is write a note on the embedded system core. Okay, what is the core of embedded system? And with a neat diagram, I have to explain. The core of embedded system is essentially it's the processing unit from where all the things happen. Okay, and the key components inside the core are, the first one is microcontroller. Okay, it consists one or more of the following units. First one is inside the core of embedded system. Okay, this is the embedded system which is present in the objects. Inside that there is a core. Inside the core there is few things. The first one is microcontroller. Microcontroller is used for the embedded system. It is a self-contained integrated circuit. It has the memory and the peripherals for the input output. Okay, examples include A051 AVR. Next is the microprocessor. These are more powerful processing units than MCUs. Okay, its process is to execute the functions required using the external memory and the peripherals. Okay, that is the second component. And third one is the digital processor. DSPs, digital signal processor, are designed for audio processing, image processing, and telecommunications. Next one is field programmable gate array. These are flexible hardware structures that can be configured by the user. Okay, and inside each of these we have the CPU core, which is the actual place where the calculations happen. Control unit is present and register is present, and the memory includes both the flash memory and the RAM memory, and peripherals include how to interact from the internal world to the external world. So these are nothing but the USB cables where we can plug in and connect another device. So those things are peripherals. Okay, the input output devices. And timers are present for the communication interfaces. Other devices and protocols are used like UART, and analog digital converters are used. Digital IO pins are used, and external devices like sensors, actuators are also used. Okay, so all of these form a embedded system. Okay. Next one is write a note on transducers. Explain one type of sensor and actuator with its operation. You have to understand what is transducer, what is sensor, what is actuator. Okay, very simple. Transducer is that which converts energy into form of electrical signals. Okay, like sound, light, or heat to electrical signals. An example can be loudspeaker. Loudspeaker, what happens? It converts the electrical signals to the sound waves. Right. In the loudspeaker, we'll be able to hear voice. Right. From where we are able to hear voice, from conversion of electricity to the sound form, that is transducer, which converts electricity to sound wave. Another, the reverse transducer, is which converts the sound wave to electricity, that is nothing but a microphone. In microphone we have input as the sound, and the output will be saved in the form of electricity, right? That is called as a reverse transducer. Both are transducers will convert one form of energy to electricity and vice versa. Okay, second is sensors. It detects some change in the aspects, okay, like distance, velocity, acceleration, temperature, pressure, light, and it notes it down. Okay, it can be either passive or active. Active generates an electricity or the current output, and the passive one does not do that, it just modifies it in some way. Okay, and the sensors can also be digital or analog. It can be on or off, 0 and 1, and so on. Actuator is nothing but it takes an action. Okay, whenever a change has happened, it can take an action. For example, if in the light emitting diode, if an electricity has changed, light will be emitted, right? So that is a actuator, okay, which converts the actual into an action. Sensor will sense it, actuator will do the action. Okay, next one question is explain how 7 segment display can be used to display the data. Write a brief note on operation of LED. Okay, so here the 7 segment LED will be like this. Here it will be 1, 2, 3, 4, 5, 6. Okay, this is just one. Okay, 1, 2, 3, 4, 5, 6, and how it is 1, 2, 3, 4, 5, 6, 7. Okay, like this it will be. And in these combinations, whatever we light, we can write any number here. Okay, this is a 7 segment display. Okay, that's all what you have to write. Okay, about the 7 segment display, this is the circuit diagram. Okay, next is what is an embedded system, and explain about the brief different elements of an embedded system. Okay, so it is an what is an embedded system? We just discussed in the first question. It is an electronic or electromechanical system designed to perform a specific function and a combination of both hardware and firmware softwares. So few of the types of the elements of the embedded system. Okay, how many elements are there? Few elements are there. First is we'll discuss what are the hardware elements. In hardware elements we have the processor, which is the brain of the system, which does the operations. Okay, it can be either a microcontroller, microprocessor, or a digital signal processor, or a combination of each of these. Next is memory. We have the flash memory or the rom memory, or a permanently storage memory. Peripherals for communication with the internal and external world. Sensor, the devices which detect the physical quantities, and actuator which take an action based on that change. Next is software. It will have any program running in the backend, and operating system will also be there, real-time operating systems, and application software to visualize all of those things which are programmed. That for that we'll be using an application software. And communication interfaces through various protocols, or like the wireless protocols like Wi-Fi, Bluetooth, all of these to communicate with the other devices. These things are present. Five things are there in hardware, software, real-time operating system, application software, and communication interfaces. Okay, now, what are the classification of embedded systems? You can remember any of the classification. Okay, there are many criteria in which the classification has happened. So we'll discuss few of the criteria. If we go with the generation, based on the generation, or we can go with the complexity and performance, or we can do with the behavior, or the triggering. The first is the classification based on generation. There are five generation of computers. In the first generation, it was 8-bit, and like the digital telephone keypads. Then it became 16 bits, and the example is the SCADA systems. And third generation, we have the 32-bit with DSPs and application specific circuits, ASCIIs, and examples are robotic and media. Fourth generation, 64-bit with the system on chip and multi-processor core. And the fifth generation is the one which are the mobile phones and all. Okay, like the smartphones with advanced technology in it. If we go with the complexity and performance, small scale it can be. Okay, it is used for simple applications like an electronic toy. Medium scale is used in industrial machines, and large scale will be used in the mission critical applications. Okay, it will be 3264 RISC architecture. Okay, if you go with the behavior, classification will be based on two types: soft time real system and hard real time system. Soft time real system means there can be delays in between, but hard real time system cannot have any delays, or it will be a very big consequences. Okay, if you go with the triggering, there can be two types: event triggered and time triggered. Event means some if some event happens, based on that some action will be taken. Time triggered means on every time limit something will happen. Okay, that kind is called as the time triggered. The last one is the difference between RISC and CISC. Okay, RISC is reduced instruction set computing, and CISC is complex instruction set computing. Okay, this is a simple one. This is a complex one. Okay, this is a simple one, and this is a complex one. This is related to a software, and this is related to hardware. Okay, and here it deals with the compiler, and here it deals with the processor. Okay, here it is single clock cycle. Here it is multiple clock cycle because it is more complex, right? And transistors are used for storing memory. Here it is used to store instructions. Okay, and RISC uses fewer instructions. Here it uses more instructions. Fewer addressing modes, more addressing modes. And fixed size length, variable size length means this is first version, this is second version. Okay, this is lower and this is higher, like that. Okay, we can do the key points for that. Yeah.
The next question is differentiate between microprocessor and microcontroller. Okay, microprocessor are widely used in computer system, whereas microcontroller is used in embedded system like washing machine, refrigerator, air conditioner. Okay, it has only a CPU embedded into it. It has a CPU fixed amount of RAM, ROM, and other peripherals embedded onto it. So this is a larger one. Okay, in case of microprocessor, we have to connect all the components externally so that circuit becomes large and complex. As all the components are internally connected, microcontroller the circuit size is less. Okay, and it consumes more power. Here it consumes less power. Used for high scale application, used for low scale application, high processing power and low processing power. Any 5 points you can remember. Few more points are there, you can go through it. Draw a block diagram of instrumentation system and explain. So physical quantity, it goes to the sensor, it senses it. Then the signal conditioning happens, the signal is conditioned, and then the processing happens. Okay, both the side, the display and the recording happens, and then finally we get the data output. Okay, instrumentation and the control system, it measures the physical quantity that is to be measured, like temperature, acts upon a sensor that produces an electric output signal. Based on the change in the temperature, the electrical output signal is produced. Okay, the signal is in electrical analog of the physical input, but note that there may be not a linear relationship between physical quantity and its electrical equivalent. Means if more temperature changes, it is not necessary that more electrical change will also be there. Okay, so that is what is the instrumentation system, which converts the physical change to electricity. Okay. What are sensors and actuators? Sensors are the one which detect or measure physical quantity, and actuators are the one which does some act on it. Okay, means if change there, then some trigger will happen and something will get executed. So sensors example is temperature sensor, light sensor, pressure sensor, proximity sensor, and gas sensor. Its task is to sense the input elements of a system. Okay, actuators are the one that receives an electrical control signal and converts into physical action. For example, electrical motor, servo motor, relay, solenoid valve, LED, and buzzer. These are output elements of the system. It does some tasks. Okay. Next one is compare RISC and CISC architectures and GPP and ASIP processors. So RISC and CISC we have already discussed. Let's discuss about the GPP and the ASIP, which is this is generic applications and this is specific applications. So here it will be having fixed, generic, moderate, higher, very high for performance, power consumption, flexibility. Whereas here it will be high for target application the performance and lower for the power consumption. Flexibility will be limited because it is for specific one, so we can't be flexible here. Cost is low because it is used for generic purpose. Here it will be higher because it will be used for specific purpose. Time to market is short, here it will be longer, and the examples also given here. Okay, those are the difference between generic and application specific processors. Next is write a short note on sensor, actuator, and LED displays using embedded system. Sensors and actuators we have already discussed. It has been repeated more times, so don't miss this question. Okay. And LED is a single LED. There are types of the single LED indicator, 7-segment dot matrix. It is nothing but that which is light emitting diode. It is used to display numbers or alphanumeric information. Features are low power consumption, high brightness, long life, and fast response time. Applications are in digital clock, counter meters, and status indicators, and embedded devices. Okay. List out the major applications of the areas where embedded systems are used. It is used in consumer electronics like washing machine, microwave ovens, and smart TVs. Automotive systems like engine control unit, airbag system, and ABS anti-braking system. And industrial automation, PLCs, robotic arms, process control systems, CNC machines. Medical and healthcare like ECG machines, patient monitoring system, and infusion pumps. Telecommunication system like mobile phones, routers, switches, home automation, smart lighting, security systems. Aerospace, it also used wherein the flight control system, missile guidance, and radar systems. Banking and financial systems in ATMs, POS terminals, and smart cards. Computers and peripheral devices, which are the devices which connect to the computer, like printers, scanners, keyboards, and hard disk controllers. And energy and power systems, transportation systems, as well as IoT. Okay, so these are the places where embedded systems are used.
The first super important question and the most repeated one from this module is state and prove De Morgan's theorem with its truth table. Okay, so what does De Morgan state? The De Morgan theorem states that the complement of logical OR of at least 2 billion variables is equivalent to the logical AND of complemented variable, each complement variable. Okay, so if a plus a1 plus a2 plus a3 till an, if we take the complement of it, that will be equivalent to a a1 and a2 a1 bar and a2 bar and a3 bar, like that. Okay, the or operation gets converted to AND operation, and each of these values which gets converted to its complement form. Okay, and these both are equivalent. Okay, so if we take with two boolean variables, it will be like this. If a plus b, a or b, if we take the complement, we'll be getting a complement or b complement. Okay, a plus b bar is equal to a bar or a bar and b bar. Okay, a plus b plus c bar is equal to a bar and b bar and c bar. Okay, so this is the equation, and the reverse is also true. If we take a1 and a2 and a3, the whole bar, will be getting a1 bar or a2 bar or a3 bar till an bar. Okay, so the following for this also, a and b bar will be a bar plus b bar, and abc, if we take, it will be a bar plus c bar plus d bar. The input and the output form will be like this. You will be writing ab and then 0 0 1 1 0 1 0 1. If a and b both are 0, output is 0. If a and b is 0 and 1, the output is 1. If it is 1 and 0, it will be 1, and if it is 1 and 1, it will be 0. Okay, so a bar b and ab bar and the minterms have the output 1. Okay, in these two cases the output is equal to 1. See, if we take a bar b, okay, that will be a bar is 0 here and b is 1 here. That's why it is a bar b, and it is 1 here, so it will be a and b bar. Okay, so if we take the OR operation of both of these, we will be having this equation. Okay, and we need to prove the De Morgan's theorem using a truth table, right? So this is the truth table. Okay, first we have a and b here, a bar and b bar. This is a plus b bar, a bar or b bar and ab, and a or b bar and a bar or b bar. Okay, so the equivalent forms are these. Okay, by the De Morgan's theorem, a plus b whole bar should be equivalent to a bar and b bar. Okay, a plus b whole bar, where it is, a plus b whole bar, a plus b whole bar is here. Okay, so this term should be equivalent to a bar and b bar. Okay, a bar and b bar, see, both of these are equal. Okay, that is one thing. Second thing is here, a dot b, a and b bar. Okay, a and b bar, where it is, a and b bar, this one should be equivalent to a bar plus b bar. Okay, a bar plus b bar, as you can see, again these both are same. Okay, you can calculate it and see. If I take an example for one of them, see, a is 0, b is 1. Okay, so what is a and b? A and b will become, see, we are taking for this one. Okay, a and b, it will become 0. What is 0 bar? 0 bar is 1, so 1 is written. That is equivalent to here. What is a bar? A bar is 1. What is b bar? 0. 1 and 0, you will get here 1 and 0. If we take the OR operation of 1 and 0, what we get? 1 only, right? So these both are equivalent. Okay, this is true for each of these. Okay, so that was about the De Morgan's theorem, and for the three tables also it's the same thing. These both are equivalent and these both are equivalent. Okay, you can verify it. Next super important question is related to nines complement method. Okay, this is also a very repeated question. How do we do the subtraction using nines complement method? Okay, so the question given is 4,637 minus 2,579. Now, if you want to subtract it, first thing what we do is find the nines complement of the subtrahend, which is the right number. Okay, 2579 is present in the right side, so that is subtrahend. We have to find the nines complement. How do we find the nines complement? Subtract this number from 9999, we'll get a value here. Then add this value to the minuend. Minuend is the one which is subtracted from. It's 4637. 4637 plus 7420. When we do, what happens is we'll be getting a 5-digit number. Now 5-digit number means there is a carry. Okay, if 4 are there, means it should, we should get the value 4. If you are getting 5, means there is a end carry. Okay, so end around carry, that is nothing but 1 here, which is the end around carry. The last which is present is, this is the end around carry. Okay, if there is an end around carry, in that case what we should do, discard it and add 1 to the remaining digits. Means 1 will be discarded, so what will be remaining? 2057. From for 2057 we have to add that 1. Okay, so when we add that 1 to 2057, we're getting 2058. This is the final answer. Okay, these are the steps you need to follow. We'll solve another question. 125 minus 1800. Our first step is to find out the nines complement of the subtrahend, which is, we'll be getting 8199. Okay, now 125 is 3 digits and this is 4 digits, so we'll be making it 4 digits by adding 0125. Okay, now we have to add the minuend to the nines complement. 0125 plus 8199 will be getting 4 digits only. Since there is 4 digits, 4 digits only, there is no end around carry. Okay, 4 digits, if it results in 5 digits, then there will be a end around carry. If there is no end around carry, what we have to do, take the nines complement of the result and make it negative. Take the ninth complement of the result and make it negative. So what is the result we have got here? The result we have got is 8324. For 8324, what we will do? We will subtract it from 9999. Okay, and we'll get 1675 and make it negative. So answer of this will be minus 1675. Okay, this is how you do the nines complement method. Don't miss this question. Okay, solve a few more questions from the same topic. Next, with the help of a truth table, explain the operation of full adder along with its circuit. So this is also very important question. Here will be two inputs will be there, A and B, and this is the carry input. Okay, and output will be having sum and carry. Okay, and this is a circuit diagram, and the truth table will be as follows. Here there will be input. Okay, A, B will be the input, and C is the input carry. 0 0 0 0 1 1 1 0 0 1 1 0 1 0 1 0 1 0 1. Okay, now sum will be A plus B. 0 plus 0 is 0, and since there is no carry, there will be no carry, 0 only. 0 plus 0, again the sum will be 1, because we are actually calculating 0 A plus B plus C in. Okay, 0 plus 0 plus 1 is 1, sum carry will be 0. 0 plus 1 plus 0 is 1 again, and the carry is 0. 0 plus 1 plus 1. What is 1 plus 1? 1 plus 1 is 1 0. Okay, 1 plus 1 is 1 0. Okay, 1 0. What is 1 0? 1 0 is 2, right? 1 plus 1 is 2, so 1 0 is 2. In 1 0, we will be taking this one as carry. Okay, this one will be carried and the sum will be taken as 0 only, like that. Okay, 1 plus 0 plus 0, again 1 and 0. 1 plus 0 plus 1, again 0 and 1, carry will be 1 and the sum will be 0. 1 plus 1 plus 0, again the carry will be 1 and the sum will be 0. 1 plus 1 plus 1, now again if we add 1 here, what will become 1 1. 1 1 means the carry is 1 and the sum is 1 as well, so both will be 1 here. Okay, so whenever we get a 2-digit answer, the right part is the sum and the left part is the carry. Okay, so this is a truth table. And the implementation of half adder. Okay, for that was for the full adder. Now the implementation for the half adder, for the sum we'll be writing a bar plus a bar b bar c plus a bar b c bar and a b bar c bar a b c. Okay, that will be a x or b x or c. Okay, and logical expression for the carry will be the following one. Okay, so the circuit diagram is also given here, you can go through it. Okay, this will be the circuit diagram for the full adder. Okay, these two expressions you have to write, and this is the circuit diagram you have to write for the full adder, and the truth table also about how it was there. Okay, so these are things you need to write for the full adder. Next is mention different theorems and postulates of Boolean algebra and prove each of them with a truth table. Okay, so there are some theorems and postulates which you need to know. While simplifying, these all theorems are used. Okay, so you can go through it one by one. 6x like x plus 0 is equal to x plus x into 1 is x plus x bar is 1. Okay, x into x bar is 0. These all are the Boolean postulates and theorems. These can be verified using a truth table as well. You can do that if you have time, else you can just go through it once and you'll be having in mind. And each of these has a name as well. Okay, like involution, associative, distribution, de Morgan, absorption. Okay, these all theorems you'll be using for simplifying. Okay, so you need to know all of these theorems, and if they ask in exam, you can write as many as you can. Okay, so the proofs are of proofs of each of them are also given. I'll not be going through the proofs, the video will become more lengthier, you can go through this. Okay, and the truth tables also, you can prove the same using a truth table as well. Okay, and the circuit diagram is also given here. Like for example, there is a truth table given here, how can we make a circuit diagram for it? What you need to do is you have to calculate which are one here. One is this one, this one, this one, this one, and this one. Okay, so if one is this will be equal to z bar, I mean z plus x plus xz plus xy plus xyz. Okay, when we simplify it, we will be getting x plus y bar z. Okay, so this will be simplification will be done using k maps. That's a separate topic. Okay, so this is just for an example. It's given the truth table for f and the equivalent diagram which is present here. Okay, so for example, how if you wanted to make this diagram, how you will make this diagram? See, here it is having y with a knot, right? Y with a knot means y is becoming 1 and z is also becoming 1. Now we will be checking where is y1 and z1. In these two places y is 1 and z is 1, right? So this will be is taking as and here. Okay, and the or operation is happening between x and yz. Okay, so it will be x plus y bar z. Okay, x plus y bar z. Okay, so this is the diagram given. The question will not be asked like this, but this is just for the understanding purpose. Okay, implementation of boolean function with the gates. Okay, next is subtract using the r minus 1's complement method. Okay, this is another method like 9's complement method. Here we'll be having r minus 1's complement method. So question given is in the decimal form 4456 minus 34234. Okay, subtract using r complement. This we have to do it using the r minus 1 complement. This is using the r complement, and two binary numbers are given. We have to subtract it. First, using the r minus 1 complement, the step is first determine the number of digits. Larger number has 5 digits, we'll work with the 5 digits. Okay, we'll calculate the r minus 1 complement. R minus 1 means base 10 means r minus 1 means 9's complement. So the 9's complement of base 10 for this given number is 9999 minus subtrahend. Okay, so 9999 minus the given number from 5 digits we have to subtract and we'll get one thing. This thing will be adding to the minuend, which is the 4456. Okay, if you add it to the 4456, you'll be getting a number here. Now this number is also having 5 digits, so there is no end carry. That means we have to subtract this from 9999. What answer we get? We have to make it negative, same as the 9's complement here also. Okay, r minus 1, if it's the base 10, it will be 9's complement method only. Okay, second is using the r's complement base 2. Okay, for the decimal numbers it's a bit different. Both the decimal numbers are given. Calculate how many bits are there. 7 bits are there in both of them. We'll work with 7 bits. Okay, then r's complement of this one you have to calculate. How will you do that? the R's complement of base 2 is found by inverting all bits and adding 1. Okay, how do you do the R's complement? Invert all the bits. See, 1 0 0 0 1 0 0, it's there, right? Invert all the bits, so it will become 0 1 1 1 0 1 1. Add 1 to it and we'll be getting this value here. This value will be added with the first number which is given, and we'll be getting an answer here. Now this answer has 8 bits, but we were working with 7 bits, so that means there is an end carry. Whenever there is an end carry, discard this bit. That's all. Discard this bit. So the final answer will be 001 and followed by 4 zeros. Okay, and 00 can be excluded because from the left part of the 1 which we have in the decimal we can exclude. So the answer will be 10000, which is 16. Okay. Moving on, few more questions we have related to the conversions from one type to a different type. Okay, like the hexadecimal, decimal, and binary. These are the most repeated ones. So let's have a look. Okay, the first is to convert hexadecimal to a decimal value. This is hexadecimal value. To convert this into decimal value. Now 3A6.C58D. Whatever the hexadecimal value is given, first what you have to do is calculate the powers of it. See, this power is 0, this power is 1, this power is 2. Okay, and 3 into 16 power 2 plus a is equivalent of 10, 10 into 16 power 1, and plus 6 into 16 power of 0. What answer we get, will be keeping it here. For the fractional part also it's the same thing. Here the power will be minus 1, minus 2, minus 3, minus 4. So C's value is 12, 12 into 16 power minus 1. 5 into 16 power minus 2, 8 into 16 power minus 3, and D is 13, 13 into 16 power minus 4. What answer we get, we'll keep it here. Approximately we'll take it. Okay, this answer approximation is this, and 934.771790 will be the final answer in decimal form. This is how you will convert the decimal value to a decimal value. Okay. Next is decimal to binary. This is the decimal value given, converted into binary. So whenever a decimal is converted to binary, the first thing you will do is multiply by 2 repeatedly. So this one multiplied by 2 is 1.375. 1 came here, take this one out. So it will remain 375. That 375 multiplied by 2, you'll get 0.75. Take this 0 out. Then you will remain with 0.75. Again 0.75 into 2, we'll get 1.5. Take this one out, and 0.5 will remain. 0.5 into 2 when we do, we'll get as 1. Take this one out. When we take the one out and the answer is 0, we'll be stopping there. And what sequence we have got? 1011, right? That will be the answer. 1011. Okay. Next is the nines complement. You have to convert this into the nines complement of it. So this is the number given. Okay, for this what you have to do, you have to take it separately. First is the integer part, second is the decimal part. 25 is here integer. For that 2 digits, so 99 minus 25 74, and 3 digits, so 999 minus 639 360. Just put it together, 74.360. Next is the ones complement. This ones complement is very simple. Convert all the ones to 0 and zeros to 1. Wherever 1 you see, put there as 0, and wherever zeros you see, put there as 1. That's all. Okay. So this is the conversions you need to know. Okay. Next is the minimization of the functions and applying the Boolean simplification functions. So minimize the following function. A function is given to us, you have to minimize it. Second, this function and this function another is given. For these two, the answer we get. Okay, answer what we get for this is called as f2. Okay, answer of this is f2. For f2 and f1, after that we have to complement it. Means we have to find the complement of f2 and f1. Okay, the first thing is we have to minimize this function. Okay, we have to apply the Boolean algebra laws. Okay, so this is the function given to us, and the term yz can be written as yz into x bar plus x. Okay, because x bar plus x will be equal to 1, yz into 1 is equal to yz only. So we can take this term instead of yz. Why we want to take this term? Because we want to simplify. X is here, x dash is here. If we take it like this and expand it, we will be getting x bar yz plus xyz. Okay, x bar yz can be taken with this term, and xyz can be taken with this term. Okay, that's the same thing which we have done here. After this, okay, after we have taken this value here, okay, yz can be written as xyz plus x bar yz. Okay, so instead of yz here, we will be writing this term. Okay, these two are same here. If you observe, xy plus x bar z is same here, but yz is written as xyz plus x bar yz. Now we will be grouping the terms. We'll be taking xyz with xy and x bar yz with x bar z. Okay, so xy plus xyz, x bar z plus x bar yz. Okay, Now when we do that, we'll take the common ones. The common ones here is xy. If we take xy common from this, we'll be remaining with 1 plus z. X bar z, if we take common, we'll be remaining with 1 plus y. Okay, and 1 plus anything will be equal to 1 only. This is another law. 1 plus whatever it is, because or condition, right? In or, either of them should be true. Okay, so no matter what this is true, means the final answer will be true. So this will be true, means we can take this whole thing as 1. This also we can take the whole thing as 1. The final answer will be xy plus x bar z. That will be the final answer. So we just remove this term, right? This yz was here, we just remove that term because that is redundant one. Okay, so the final minimize function is xy plus x bar z. This is the f2. Okay, this will be used in the next function. Now next question they had asked is to find the complement. Complement of this is nothing but we have to just take a bar on top of it and apply the De Morgan's law. See, this is nothing but xy z x bar y z bar plus x bar y bar and z, right? You have to take its complement, means you have to do like this. If you apply the De Morgan's law, what will happen? We'll be taking this term here, x bar y z bar, and this will plus will become dot, and this will be x bar y bar and z, and another not operator on it. Okay, so when we do it individually, we will be getting our final answer, which is x bar sorry, this will be the final answer. Okay, this will be the final answer. This one. Okay, this one will be getting the final answer when we simplify this one. Okay, so again from there also we'll be applying a De Morgan's law. Okay, so see, I'll be explaining what's happening. See, x bar is here, y and z bar is here. Okay, plus x bar, y bar, and z is present here. You have to take the complement of it. F1 is given this one, you have to take the complement. So we took the complement. Okay, if we take the complement, we have to separate the terms and separate the sign also. This is plus, this will become multiplied. Okay, x bar, y bar, z, and again this one. Now again here also we'll be applying the De Morgan's law. When we apply the De Morgan's law, this is dot here and dot here, right? Because this is and operations on in between them. When we remove the and, it will become plus. So this will become x bar double bar plus y bar plus z double bar. Okay, one bar is already here, so it will become. Now double bar is nothing but it is 0. Okay, so means it will get cancelled. Not of not is this initial thing only, right? So it will become x plus y bar plus z, and this also when you do it similarly, you will be getting this one, x plus y plus z bar. Okay, see, this will become x double bar, that is equal to x only, and plus will be here, y double bar is y only, and z will become z bar. Okay, so x plus y plus z bar, x plus y plus z bar, x plus y bar plus z, x plus y bar plus z. This is the final answer. Okay, so f2 also will be doing the same thing. F2 is given as xy plus x bar z whole bar. So when you simplify it, you'll be getting this answer. Okay,
The next type of question which can be asked is regarding the conversion, okay, from the base 10 to base 2 to base 16 and from base x to base 8. If the number is given, how do you find x? And if it is 8 to 16, how do you do that subtracting using ones and twos complements? Okay, so all of these things you have to practice. I have included it here. So don't skip it. This is a very important concept from this module. Okay, so final binary values, whichever you get, you just verify it once you obtain it from your own answers. Okay, so once you have to convert the change the decimal means the base values from 10 to 16 to 8, you have to divide it by that number. Okay, so you'll be able to change it. You'll keep on dividing, and whatever reminders you are going to get, right, that reminders you have to take into consideration. Okay, so all of those answers are like that only. And subtraction also I have already discussed how do you find out the complement and subtract it. In the same way you have to do these also. Okay, these are the further important questions which you do not have to miss. Okay, next one is simplify the following Boolean expressions. Okay, Boolean expressions are given. Obtain the canonical forms. Okay, so here are all the canonical forms that you need to do. The SOP form, the post form, all of these things are important. And the questions which are included here are from the previous papers and the model question paper. Okay, so don't miss any of these questions. These are the most important ones. And design a full adder circuit using the basic gates. Okay, full adder circuit will be having 3 inputs, 2 from the normal input and 1 from the carry input. Okay, and 2 outputs will be there, C out and sum out. Okay, so definition of the full adder would be it adds 3 bits. Okay, A, B, and the carry input and produces 2 outputs, sum and carry out. This is the first thing you need to write. Next is inputs and outputs will be writing here, and using the logical expressions, you'll be writing the equations for the sum and the carry out. Okay, finally you have to write these two. If you don't write, you might lose some marks. Okay. Next is express the Boolean function in the product of max terms, as well as conversion is there. Okay, so as you can see, this is so much important here that you do not miss these kind of questions. Okay, when you have to do the pos and the SOP conversion and the conversions of the different bases. Okay, decimal, octal, binary, and yeah, these three are the most important ones. Okay. Hexadecimal is also there. Okay, so just go through it once and try it from your own. And yeah, the other one is the subtract the following using the tens complement. Okay, using the tens complement you have to subtract it, so you'll be converting it in this way: 0 3 2 5 0, and then you'll be subtracting 7 2 5 3 2 from 0 3 2 5 0. Okay, so the tens complement, when you do that, nines complement is also given here. They will be getting the end answer here. Same way you have to do this one also. Okay, and conversion is given here. Few more questions are there for the basic Boolean theorems to prove. This is the theorem proving using the Boolean algebraic laws, and explain ones and twos complements method with examples. Okay, ones and twos complement we have already discussed. Few more questions are given here. Okay, just go through it once. Okay, and explain the ones and twos complement. This is the answer which you need to write in the exam. And explain the design procedure for the combinational logic circuits. Just suitable example. Okay, combinational circuits are the ones which will be having n input variables and outputting m output variables. A combinational circuit consists of logic gates whose outputs are determined directly from the present combination of the inputs at any time. The combination is important here. Based on the combination, the output is figured out. Okay, and design procedure. The problem is stated, number of available input variables are and the required output variables are determined. Input and output variables are assigned to the letter symbols. The truth table that define the required relationship between the input and the output is derived. Simplified Boolean function for each output is obtained. Again, the logic diagram is drawn. Okay. So the Boolean expression, the other question is about the expressing of the Boolean expression in sum of min terms. Okay. So practice these questions very well when you have to write the min terms and the max terms. Write a short note on half adder and its truth table. Just as you have done for the full adder, like that only in half adder we will be having the inputs A, B and the outputs will be sum and carry. Okay, that's all. Two inputs and two outputs, and you have to finally write the equations for the sum and the carry. Okay, and also write the truth table, explain its working and the applications. And finally write a diagram also. Okay, so that's all for the super important questions on the electronics. And if you found this video helpful, please like and subscribe. It has made more videos like this. And thank you so much for watching. I'll see you in the next.